today's video, we're going to be talking about multiplying and dividing rational expressions. And the key to multiplying and dividing rational expressions is to factor cancel. Factoring is going to play a big part in this. So if you do struggle with your factoring skills, there is a factoring review video that's posted that is optional that you can watch if you need help with your factoring. All right, so as I said, it's all about factor cancel. So number one, we're not actually going to be multiplying and dividing yet. We're going to be working on our factor cancel skills. On top, we have a trinomial. The leading coefficient is a 1, so this is going to be regular factoring. Remember, for regular factoring, we're working on multiplying to the outside and adding to the middle. So the two numbers that multiply to 8 and add to 6, well, that's 4 and 2. And on the bottom, we're multiplying to 4 and adding 4. That's 2 and 2. So we make sure that we've completely factored the numerator and completely factored the denominator, and then we're going to see what cancels. I see that I have an x plus 2 and an x plus 2. When you are canceling, it is important that you are canceling entire terms at a time. I can't just cancel the x's or just cancel the 2's. I have to cancel the entire piece of x plus 2. So this leaves us with x plus 4 over x plus 2. This would be your final answer. Again, you would have to cancel out this entire binomial. I can't just cancel the x's out. If it's more helpful, sometimes we like to keep the parentheses there to remind us that those have to stay together. So you could write your answer either way, whichever is most helpful for you. Now when we get to number 2, we're still just working on our factor cancel skills here, but we've increased the difficulty of factoring. So again, this is where that factoring review video is going to come into play if you need help. We've got x cubed minus 8. This is the difference of cubes. My a term here is x. My b term is 2. Remember, your a and b is what number do I have to cube to get there? And then your difference of cubes pattern is going to be a minus b, a squared plus a times b plus b squared. So I did the difference of cubes on top. When we go to the denominator, I see that I'm looking to multiply to 4 and add to 2. So I think about all the different ways I can multiply to 4. It's 2 and 2 or 4 and 1. There's no way that I can multiply to a positive 4 and also add to a positive 2. So this trinomial isn't factorable, and we know that sometimes not everything is going to be able to be factored. So I look to see what I can do. I've got x squared plus 2x plus 4 on top, and I've got x squared plus 2x plus 4 on the bottom. And just remember that we don't cancel individual pieces, we cancel the whole term, the whole expression at once. So here, the only thing I have left is x minus 2. There's nothing left on the bottom, so we no longer have a fraction, we just have x minus 2. All right, let's get into some division now. Division and multiplication, we're going to do exactly what we did in simplifying. We're going to work with factor cancel. So when I look at the first one here, I have 4 terms. The only way to factor something that has 4 terms is to factor by grouping. We pull out the GCF from the first term, which is x squared, leaving us with x plus 6. Over here, I pull out a negative 1, which also leaves us with x plus 6. Remember, that's the key with grouping, is we need that same piece to be inside. So when I pull that, that gives me x squared minus 1. That's my first factor. And x plus 6. Now we need to be really careful here. I need to pay special attention to this because that's actually not done yet. We're not done factoring that. That's the difference of 2 squares. So really this is x plus 1 and x minus 1. And it's kind of up to you on how many different steps that you want to rewrite this. Like I did some factoring up here. Normally I would take this and then go to the next row, but we can see that that's x plus 1, x minus 1. Just make sure that you leave it to a point where it's organized for you to know what pieces go where. On the bottom, we're multiplying to a -2, adding to a -1. So that's x minus 2 and x plus 1. That's just regular factoring. Over here, we've got x squared minus 4. That's the difference of two squares. So that's x plus 2, x minus 2. On the bottom, you may be thinking that you have to do Batman, but you don't. You pull out that GCF, which leaves us with 8x and 12. So now we've got regular factoring. Multiply to 12 and add to 8. That's going to be 6 and 2. So in the beginning I said I probably would take this to one more step. I don't like it being messy like that, so I would have left it as x squared minus 1 there and then just brought it down to x plus 1, x minus 1. Just rewriting everything. I like to be able to see everything at once. Again, I don't want to have any confusion of where my pieces are. So I have everything factored as far as I can possibly go. Now it's about canceling my pieces. And the key is anything on top can cancel with anything on the bottom. It doesn't matter if it's the first fraction or the second fraction. So I see an x plus 6 here and an x plus 6 there. Those two are going to cancel. Because I'm multiplying my fractions together, everything on top can become part of one numerator and everything on the bottom is one denominator. So I'm just looking on top and bottom for things that are going to cancel. See an x plus 2 and x plus 2, x minus 2, x minus 2, x plus 1, x plus 1. So when all is said and done, I got a lot of things that canceled. I look across the top. The only thing I have left in the numerator is this x minus 1. On the bottom, the only thing I have is a 2. So I've got x minus 1 all over 2. Now division is the same thing as multiplication, but think about the fact that we are dividing by a fraction. And we don't like to divide by fractions. Instead of dividing by a fraction, we multiply by the reciprocal. So what I have to do here with this second term is I have to do the reciprocal of it. I'm going to change the division to multiplication, and I'm going to use the reciprocal. In number 2, we have, on our numerator, we have the 3 pieces. Our leading coefficient is not a 1. When we didn't have a leading coefficient over here in number 1, I was able to pull out the GCF that allowed it to become regular factoring. That's not the case here. This is Batman factoring. So when I factor that trinomial, I end up with 3x minus 2 and x plus 1. Again, if you struggle with Batman factoring, go back to that factoring review video. On the bottom, that's regular factoring. I'm multiplying to 2 and adding to 3. Well, that's plus 2 and plus 1. So now, instead of dividing, we multiply by the reciprocal. So the x plus 2 goes on top, the 2x goes on the bottom. Nothing was factorable in that second piece, but if it was, I would factor and then I would switch my pieces. So we're at the point we make sure that everything is factored as far as it can go, and then we start canceling our pieces out. I've got an x plus 1 and x plus 1, x plus 2, x plus 2. That's all I can do. So I've got a 3x minus 2 in the numerator, and I just have the 2x left in the denominator. Final answer. Don't forget, these x's do not cancel. You have to cancel the entire expression at a time, unless it's part of the GCF. Okay, our last one here, and we can see in number 3, we have a combination of multiplication and division. So we're putting all of those pieces together. I've got my first term. I see here that the only thing I can do is pull out a GCF. So I pull out that x, leaving me with x plus 11. Nothing can happen on the bottom there. The second piece, we don't actually have a fraction, but we know that I can make it into a fraction by simply putting it over 1. Because this is division, I am multiplying by the reciprocal, so I'm going to switch the numerator and the denominator. When you're dividing, you only do the reciprocal of the one piece that you're dividing. I'm not going to do the reciprocal of this last piece as well because this is a multiplication symbol. So I'm only flipping this one expression. And that one expression, I do have stuff that can factor. I can pull out the 3, so that's 3x plus 2. When I go down here, the reciprocal puts the 1 in the numerator and the 3x plus 2 in the denominator, multiplying by that reciprocal. And I'm not going to flip that second piece because I'm not dividing by that second piece. You only do the reciprocal of the one piece that you're dividing. Maybe you're dividing 2 pieces and you flip both of those, but only divide the one expression that has the division symbol by it. In the numerator here, we have the difference of 2 squares, so that's x plus 2, x minus 2. On the bottom, we've got x plus 11. We start our canceling, x plus 11, x plus 11, x minus 2, x minus 2, x plus 2, x plus 2. So I look at everything I have on top. The only thing I have left is an x and a 1. Well, x times 1 is just 1x. On the bottom, the only thing I have left is a 3. So my answer is x over 3. Now let's say we had missed the x plus 11. That's okay. If you didn't cancel that in the first step of canceling, once you get down to this answer, you just want to double check, is everything simplified as far as it can go? And maybe you missed something. That's okay. Just keep on factoring or keep on canceling until everything is gone that matches. All right, that is our multiplication and division of rational expressions.